Good day, everyone. It's Alan Schimmel from DevOps.com, and you're listening to another DevOps webinar. Thank you for joining us. Today's webinar promises to be a great one with two fantastic panel members. The title of today's webinar is State of DevOps 2018, Continuous Testing is Required for DevOps Success. Yes, no, maybe, we think it is, you'll hear from our speakers on it in any event. We also have, though, even a little bit more of surprise content for you that we're going to get to in just a moment. Before we do, though, we use the GoToWebinar platform here for our webinars. And one of the nice things about it is the ability to interact with the audience on several levels. One of the ways we interact is through our question session. We have set aside time for questions at the conclusion of today's webinar. And if you look at your GoToWebinar control panel, you'll see the little section marked questions. And if you click on the arrow or caret so that it's down facing, you'll see it expand. You can type your questions in there in real time. Please don't wait for the end of the webinar to ask your questions, because what happens is there's a rush at the end and there's only so many questions we have time for. The other thing is if you're like me, you're liable to forget your question if it's something that arises out of the discussion earlier on in the webinar versus later on. And this way you don't have to worry about forgetting it. It's in there, it's queued, we have it. And then third, even if we can't get to it online today live, we do have a written record of the question, and we can ask our panelists to try to answer for you, perhaps via email or online. So please ask your questions in real time there. We'll queue them up, excuse me, and have them ready for our panelists. I see someone's already popped a question in. Will the recording be provided? And that's always the first question. Yes, this webinar is being recorded. Yes, it will be available on our DevOps TV YouTube channel, as well as on DevOps.com, along with slides. So get that out of the way. Lastly, if you look at the bottom of your control panel, there is a section marked chat. And here on our DevOps.com webinars, we use chat for technical issues. So if your audio is not working, the slides aren't progressing, or some other issue that's preventing you from getting the full value of the webinar, but you can still get to the chat section. If you could type your issues in there, and we do have engineers standing by who will try to help you. This is not a live video presentation today, so no, I don't think we'll be able to see the speakers, though you can look on DevOps.com if you're interested to see what they look like. And with that, actually, let me introduce our speakers for today. So first of all, kicking things off will be a frequent guest on DevOps.com, as well as a very well-known person in the DevOps community, is my friend Dr. Nicole Forsgren, a CEO and Chief Scientist of DevOps Research and Assessment, or DORA as it's called. And Nicole is going to be talking about Accelerate State of DevOps, Strategies for a New Economy 2018. Nicole, welcome back to DevOps.com.
Thank you so much. I'm super excited to be here today.
We are excited to have you. Joining Nicole will be, I think it's his first time joining us on a webinar here, is Mr. Wolfgang Platz. He is the founder and Chief Strategy Officer of Tricentis. And beyond the title, Wolfgang's a very well-known person in the testing world, with over 20 years of technology experience prior to founding Tricentis back in 2007. Wolfgang brings just a lifetime of experience. Wolfgang, thanks for joining us, and a pleasure to have you here.
Thanks, everybody. Pleasure's on my side.
Okay.
And, happy to talk to you guys later.
Absolutely. So I think the way we've decided to divide and conquer today is, Nicole, we're going to hand it over to you first, and you'll be presenting a little bit about Accelerate.
Yes. So yeah, I think what we're going to do is I'm going to walk through some of the latest findings of the 2018 State of DevOps report. I'm going to talk about what we found, and I'm going to tee it up because I'll give you a little bit of a teaser. We found that continuous testing ends up being a strong predictor of SDO performance. And some of you are like, SDO performance? Nicole, what are you talking about? Well, stay tuned. So here's what we found. So the Accelerate State of DevOps report is the largest and longest running research of its kind. So let me take a half step back. Who are we, right? So DORA is the team behind this long running research report. It's myself, I'm the lead investigator and chief scientist. It's also Jez Humble and Jean Kim. We've been doing this research for 5 years. It's academically rigorous research. The data set covers over 30,000 professionals worldwide. We really look at the practices and capabilities that drive software delivery performance. And what we know is that higher software delivery performance really does drive strong business outcomes, both commercial and non-commercial. It's the only report that looks at performance benchmarks and performance profiles that uses strong statistical methods and data-driven methods so that we can all see how we compare to the industry. And then most importantly, so I tell people, it's interesting to know how you compare to the industry, but that's kind of a party trick, right? We want to know how we compare, but what's most important is knowing how we get better. And so we also include predictive analysis so that we can see, what our specific improvement strategies are. So key themes for this year is, as I mentioned, SDO performance. So this is software delivery and operational performance, or if you like the word services, you can say service delivery and operational performance. So this really is a key driver. Now, I say operational performance. This is new this year. So we expand our operationalization of software development delivery to include availability this year. That's what I mean when I say SDO performance. Another big theme is, what are the key technical practices that drive SDO performance? So we expand on and iterate on our research from the previous 4 years to include a few extra key practices, to include monitoring and observability, as I mentioned, continuous testing, database change management, and shifting left on security. We also look at key technical practices that drive performance. Things like influencing culture through autonomy and trust, and also creating a culture of learning through things like retrospectives. Now, these are some of our key findings this year. Our elite performers, our highest performing group, can do some amazing things. We see that they have 46 times more frequent code deployments. They're able to have lead times that go from commit to deploy over 2,500 times faster. We also see 2,600 times faster time to recover from incidents, and they have a 7 times lower change fail rate. Now, that allows us to delight our customers, deliver features faster, to beat our competitors to market. This allows us to keep up with compliance and regulatory changes. It allows us to do so much. So again, we can deliver on our promises and really get these business benefits that we keep talking about. So when we look at these trends year over year, it's really interesting. If we look at the trends 2016, 2017, 2018, we see this great trend, right? Deployment frequency, lead time for changes have been relatively stable, right? We've seen a little bit of move up and down. We see a huge, increase in change year over year, though, particularly in our stability metrics, right? The green triangles, these two things at the end, growing year over year, time to restore service, change fail rate. Some people have asked why this might be the case. We think it can be a few things. We think it can be the push for speed, right? It's so difficult to feel like you have to keep up with your competitors and feel like you have to keep up with the market. We think that's also combined with growing complexity in our systems, right? Which happens year over year over year. Now, what are some key differences that we've seen? One, again, as I mentioned previously, we added availability. So in previous years, we focused on software development and delivery. So our previous models and our previous analysis has looked at lead time and deployment frequency, change failure rate, and time to restore service. Now, this year we added availability. So what do we mean by availability? This really is teams and how they're making and keeping promises to their end users and their customers. What we found is that by adding availability to our model, the service operation piece, it makes our ability to predict organizational performance outcomes much stronger. We also see that elite performers are 3.5 times more likely to have strong availability practices, and it really rounds out this model much, much better. So if we take a look at our elite performers, data shows this new fourth high performance group. Now take a look at this graphic because I think it's really important to call this out. Elite performers are a subset of our high performers. Here's something else that's interesting to call out. Our high performance group is 48% of our total population. This is huge. It's really interesting because we've seen and we're noticing year over year, these high performers are growing. And I think it's really good and really encouraging to point out because this is possible for everyone. It's all about execution. And I think that's something that, that's a theme that that for me is the theme out of this year's data, right? It's all about execution. High performance is possible for everyone. If we think back to those slides a couple of minutes ago, some people can look at that and they may think this is so discouraging, right? Low performers are just trailing behind. They're really falling behind. Not necessarily. I mean, they are if you're not executing in smart ways, but the high performance group is growing. And the elite performers are very similar to what our high performance group has been in the past. So what it means is that our high performance group is getting bigger and bigger and bigger, right? Our elite performers, the best of the best, continue to optimize on speed and stability. So some key topics of interest. This table is the one that everyone loves to look at first. So let's take a look at our elite performers. Again, they're optimizing on speed and stability. For the 5th year in a row, we see that the best teams don't have to make trade-offs. Okay, we see deployment frequency on demand. We see lead time for changes less than an hour. This is code commit to code deploy. For time to restore service, again, less than an hour, and change fail rate between 0 and 15%. Go ahead and take a look at this chart and see where your team might fall. Now again, notice I keep saying team. This is not at the organizational level, this is at the team level, because teams will be different across an organization. Now, a minute ago, I mentioned it's all about execution. One thing that was really, really interesting in the data here is we started by asking teams if they were in the cloud. And then we went through and we asked about essential practices and if people were doing each of these essential 5 practices. And what we found is that only 22% of teams who say they're in the cloud are actually doing all 5 of these essential practices. And by the way, this comes from NIST, National Institute of Standards and Technology. So what these 5 practices are on-demand self-service, so you shouldn't have to be opening up a ticket. Broad network access, right? You should be able to access this from any type of device. Resource pooling, rapid elasticity, right? Bursting, and measured service. So only 22% of teams that say they're doing cloud are actually doing it right. So think about it. If you're working in a team or for an organization, or if you hear of teams and organizations saying, well, we went to the cloud, but we didn't see any benefits, it's probably because they aren't really doing any of these essential characteristics or all of them. And what we see is that teams that really leverage all 5 characteristics, they're 23 times more likely to be elite performers. So again, it comes down to execution. We have to be executing on all of the fundamentals to really get the benefits. This makes sense, right? Go back to when you're in school. You can't cheat and expect to really see the benefit. Okay, Next up, open source software. We see that using open source software is highly correlated with SDO performance. And teams that use open source software are 1.7 times more likely to be elite performers. And those same teams are also 1.5 times more likely to expand OSS usage in the future. Oh, I loved this finding this year. Industry doesn't matter. It doesn't matter for achieving high performance. High performers exist in both highly regulated and non-highly regulated industries. I did a more robust and more rigorous analysis this year to really dig into it. And we see that any team in any industry can achieve high performance. I even looked across all different types of industries, and we don't see a significant impact across any of them. So my subtitle for this slide is "There's no excuse." Now, another topic, don't forget the database. Integrating database work into software delivery positively contributes in a predictive way to SDO performance. And what does this look like? This looks much like shifting left on many of the other things that we've done. Clear communication using configuration management, good visibility, including the teams early in the process. So dig into this in the report if this is something that applies to you. Now, we did talk about evolving testing, right? We did talk about automated testing, and we tested automated testing as a predictor in previous year's research. But testing has taken on such a strong and important role that we wanted to dig into it this year and see if continuous testing was important. And what we found is that it does positively contribute to SDO performance. What do I mean when I say positively contribute? It is statistically significantly important and predictive to SDO performance. So what does this mean? What does this look like? It involves several things, and it is definitely worth the investment. So having fast, reliable test suites is important. Having devs that create and maintain test suites, having data that's easily available for tests, continuously improving your test suites, right? This is a continuously evolving process. Having testers and developers that work together. Manual testing throughout the process is important, right? Manual testing doesn't go away. It's not just automating something, right? So we still have room for exploratory testing, usability testing, acceptance testing. Having developers practice TDD. And also a good strong key is being able to get feedback from test suites in 10 minutes or less. Another thing that was important is looking into our systems, monitoring and observability. Teams with comprehensive solutions here were 1.3 times more likely to be elite performers. And we found that it positively contributed to SDO performance. Now, a couple people who are in this space that are dialed in may notice that I said monitoring and observability together as if it was one thing. Many of us in the industry know that they're different. We talk about them differently. But an interesting stats fact, they loaded together. If you want to dig into what that means, go ahead and check out the report. I'm kind of running out of time, and I want to make sure I save time for Wolfgang. Now, deeper analysis. What does this mean? I pulled this from the report. Here's how to read this. Anytime you see a line with an arrow, you can read that as predicts, or drives, or impacts. Anytime you see a box with bold or all caps, that's something that's brand new this year. Anything that's not bold and caps, we were able to revalidate a previous year's finding, which also is kind of exciting, right? So what this means is that all of these technical practices on the left, deployment automation, CI, trunk-based development, and then the new things, right? Continuous testing, which Wolfgang is definitely going to dive into next, drive and positively impact continuous delivery. Which in turn drives a strong work culture, right? An organizational culture. It drives SDO performance, which in turn drives organizational performance. It's also important to point out, it helps decrease, right? It has a minus sign on that arrow. It helps decrease deployment pain and decrease burnout, which is also important. Now, a couple surprises this year. We found this other interesting performance group, right? So earlier we talked about the elite performers and high, medium, low performers. There's also this other group called misguided performers. They optimize for caution. They release code very slowly. But you know what's interesting? They have a relatively low change fail rate. But you know what happens is when they finally do release code, they have really, really long time to restore service, 1 to 6 months. At first, you know, my team thought I was crazy. We double checked, we triple checked, we quadruple checked the data, but we realized we see this in industry quite often. 5% of teams do this and they suffer the consequences. Think about, you know, one very public example was healthcare.gov. Even if teams go down or companies go down and customers may be able to access the data within days or hours, so many of our technical teams will be behind the scenes desperately trying to restore systems and infrastructure and data. So a slow, steady approach just doesn't work. Speed, stability, availability is essential. Another thing that we found is Jcurve of transformation. We've seen evidence of this for years now. Low performers actually do relatively well. We see less manual work here. You see quick wins, you see early in the transformation. And then medium performers see more manual work at statistically significant levels. What's happening there? Automation increases test requirements. Initially, we deal with this manually. Technical debt piles up. This is where test is so important here, and having a strong test suite. Technical debt, increased complexity, increase more manual work, more manual controls, extra processes. But if we can do relentless improvement, better improvement, push through this, high performers pull through with the least amount of manual work. We talk through this in the report. Outsourcing. Low performing teams are almost 4 times as likely to use functional outsourcing. By the way, remember those misguided performers? They have the highest use of outsourcing of all groups. Here quickly on the right is our lean product management model, where much of this is reaffirmed from prior years' research. And we do see that outsourcing is negatively predictive of software delivery performance. Now, major takeaways. Good ways to improve SDO performance. All of those technical and product characteristics that I mentioned, as well as cultural capabilities, are important. Also, adopting essential cloud characteristics is key. Organizations need to make smart investments in technology, lean practices, and culture. A holistic transformation is important. The data on functional outsourcing is in, right? It's just bad news. It just doesn't work. Now, this is about functional outsourcing and not about insourcing or core sourcing or group sourcing. And so we talk about that in the report as well. The highest performers optimize for throughput, stability, and availability. And it really does come down to execution. We will include a link in the show notes to allow everyone to download the full report. And thank you so much. Now I will turn over to Wolfgang.
Hi, everybody. So thanks, Nicole. This has been super cool stuff. Actually, can you change the presenter, guys? Or should I do it myself? Let me do that. Here we go. So Nicole, as I said, thanks a lot. These are really interesting stats that you shared with us. I've taken the time to pick my 2 high flyers from your presentation. One is don't optimize for caution. I like that one very much. And I find it also very interesting what you have been coming up regarding outsourcing. So let's see where that goes. So great stuff that we have heard. I would like to go more in depth on continuous testing, as Nicole already mentioned. And what I would like to do in order to get us there is, first of all, briefly give you an intro who Tricentis is, but this is gonna take like 1 minute, and then go right into depth. So we are a global company, have had some acquisitions and mergers within the last couple of months. Just to give you an idea, we're about 600 people. We're all about testing. That has always been our focus. We're 10 years around now, acting globally, as I said, and very proud to be leaders with all the major analysts. So it is a Gartner, first of all, who has called us a leader. but it is also a Forrester and an IDC. So if you may, this is like being told a AAA by Standard & Poor's, Moody's, and Fitch if you would project that into the banking space. So having that said, we are all about continuous testing. We see that agile development has been extended to the operation side. That came up with the term DevOps, which is the core topic of today's webinar. We do think that continuous testing as the bridge between development and operations is required in order to really make DevOps happen. Continuous testing, however, is a real change agenda, and most of our customers who move towards that space have, as far as I'm concerned, a little naive picture about what continuous testing means. A lot of them think it's just doing some UI test automation, which they're going to use some script-based tool and think that's going to work. However, in order to make it really happen, what we believe is it's way more than that. And what we have come up with is what we call a continuous testing maturity model, which actually describes the way to get to comprehensive continuous testing in a series of maturity levels. M1 is very basic, where a lot of our customers start with. They actually are at the manual testing. They do have some UI automation, which is usually script-based, but that's about it. And then step by step, we evolve together with them into a comprehensive adoption of continuous testing, which would be represented by a maturity level M5 here. So if you would want to see how we and DORA fit together, the way I would call it out is that DORA certainly has a focus on a comprehensive DevOps perspective. So it is about data analysis, best practices, benchmarks here alongside the full DevOps. And I see it as a very powerful diagnosis instrument. If you fill out these surveys, you will be able to have a very crisp positioning of where you are compared with these elite performers or even with the misguided performers. The CTMM has a very distinct focus now on continuous testing. It also provides best practices and benchmarks. It goes, so to say, into more depth on continuous testing, and it views itself both as a diagnosis and a therapy instrument. Diagnosis meaning, first of all, you get a projection on which maturity level you already are with your endeavor in order to get to continuous testing, and then it gives you very clear instructions of how to get to an M5, to comprehensive continuous testing. In order to make this very clear and make it tangible for you guys, I've taken a core banking solution example as a customer example, because we have done this journey together with these guys, and I wanted to give you an idea how that worked. To give you a precise position, these guys are considered to be the leaders in the financial space regarding core banking. This has been produced by Jcurve, which is part of Infosys. And let's see what we did with them. They were very much like a lot of our customers are, especially in the enterprise space. We still see in the enterprise space that there is an extreme extent of manual testing still there. We learned from Nicole before that manual testing is never going to vanish, and I agree to that. However, seeing 80% of the test work or even more done manually certainly can't be the final picture that we aim for. We see low automation rates in these large accounts. Actually, less than 20% is actually pretty optimistic. When you go into big enterprises, you will find that the automation rates are even significantly below. So the average that we see is about 10% out there. And most of the automation these days is using user interfaces as the dominant test access, and only a few go through the APIs. So that all in all is a huge technical challenge. And it also leads to significant budget and expenses on testing. 35% is what we see as an average. And if you sum this up around enterprises, you will find that this is a $35 billion market, which is just with testing services these days. And it takes a long time to execute testing, and that certainly creates a huge burden because it delays development. So let's go back and have a look at the journey that we have been going through with these folks from Jcurve in order to bring them to continuous testing comprehensively. They started at an M1, so they were very typical, like most of the customers are. A lot of manual testing, UI automation was there. It was script-based with some IBM tool set. And what we did now, the first thing is we introduced a risk-weight functional structure. And as a next step, we projected the most relevant test cases onto it. Let me explain what that means, the risk-weighted functional structure, briefly. And then we automated these most relevant 600 test cases. So back to this risk-weighted functional structure. What you see today out there, and this is quite typical, is I don't know when you had a look at a test report lately. When you see these reports, usually you see numbers of test cases and you see the test states associated to these numbers of test cases. Here in our example, it's like 53,000 test cases, 42,000 in green, 10,000 in red, 910 is white, which means these test cases are here, but we couldn't run them for whatever reason. And the question that we need to ask ourselves, seeing these stats, is, can I go productive? Well, and you're gonna say, well, I don't know. 53,000 test cases is a lot of work, certainly done, but what about these test cases? Is 10,000 test cases a problem or not? It certainly depends on the relevance of these test cases, but the numbers would not show. So in order to make this tangible, let me take an example from the car, Formula One racing. If you have a look at these different parts of a car here, right, a Formula One car, what would you guess is the most important piece of the car? So I don't know if you got it. Let me share it with you. About 3.5 million pounds out of 6 million pounds in total go into the engine. And if you take the engine and the gearbox and these parts, you're going to find out that the relevance of the engine is actually 60% of the overall. So if I would project it now in IT, tests which would focus on the engine have certainly a higher relevance than tests, for instance, for the rear wing, which has just 1.58% of the overall contribution. Why do I point this out? One of the core things in agile development is that you, in any situation, have a very clear understanding of the value of what you're doing. And when we talk about testing, it is about the flip side of the value, meaning the risk that is associated with failure. So people make themselves aware of value in agile development. Regarding testing, they need to make themselves aware of the risk that is prevented when they do that. And this actually follows what you may have seen before, the 80-20 rule. The 80-20 rule initially means that with 20% of input, you get to 80% of outcome. And this is even true when you would take test cases and sort them by their contribution. You would get to a similar picture of what you get as business risk coverage. It's actually not an 80-20, but it is an 80-30. The stats here we have got together with our partner Accenture from a series of different projects. And what we did, you remember that before, we first of all introduced a functional weighting, meaning we assigned weights to the different functional areas of the application to be tested. And guess what? It makes up a picture like this. And then we picked the most relevant test cases and introduced risk coverage as a concept. So risk coverage would tell us that if you have a certain number of tests which you have run through, we now take their contribution to the overall business risk into consideration. And when they succeed, we would add to the green bar here of success. If they failed, the red bar of failure. 15% in that particular example would be test cases that have not been run, but we have test cases. And 10% is something new, because that is actually the test leak. This is an area where you leak coverage. So all in all, this now sums up to 100%, and it takes into consideration what the relevance of the tests is regarding the business risk that is prevented when these tests run through. So this is actually the currency we would need to seek. So when we have that picture, when we have the risk coverage as an idea, we will want to automate test cases, and we will want to automate the very most relevant test cases early. So when we go automation, I need to make you guys aware that the automation is going to look different as well. Automation, which today in a lot of cases has a clear focus on UI and only small API, will look different in going forward. Automated UI tests will remain relevant. They're going to even increase in absolute numbers. However, the relative importance of the whole automation stack, which is what we believe certainly north of 85%, will be changing, and it's going to be API tests in conjunction with service virtualization will become way more prominent than we see today. Manual testing, as Nicole already mentioned, is not going to vanish. We see exploratory tests here to stay, but the classic specification-based manual testing, so to say, is going to be gone and will be all automated. So back to our example, what did we do? After having set this functional structure, which goes along with this curve here, what we did is we took the 600 most relevant test cases, which you can find. Usually people do have the most relevant test cases, even intuitively, and then we automated them right away. Through this move, the 600 were about a little less than 10% of the overall test that these guys had back then. We would get about a 40% business risk coverage, just to give you an idea. This is a very, very valuable and critical test portfolio. These are the tests which you would want to run immediately after certain changes have been committed to the repository in order to find out whether they work from an overall perspective. We call that a smoke test portfolio. So these are the test cases you would run most often in order to secure changes. So that was the first thing we did with this customer, and that brought them actually to an M2, as you see here, maturity level 2. What does the automation look like? And let me share a few thoughts on that. If you go for automation in the way that it has been always done, we think you're going to run into the same problems and same challenges ever after. And the classic changes with test automation, first of all, are the maintenance issue. Test cases, bringing them up is one thing, but keeping them alive, maintaining them is not a trivial task. And what we see is that a lot of test automation today is programming, which we think should not be the case. Imagine you bring up your own programming framework for test automation. So the question then is, who's going to test that programming framework? And all of a sudden, you might want to have another programming framework for testing the programming framework, which tests the programming code. You know what I mean? It's going to be a never-ending story. So the way we do test automation is fundamentally different. You see here a Selenium script going down, showing some test automation. And what you see here now on the left side is actually the way we provide testing, which is what we call model-based. You bring the testing into an abstracted business fashion, and that is something that everybody can use, even the former manual testers. You do not need to be a developer in order to do that. So the automation learning curve with that approach is way faster. Here's a little example which we actually got to in the course of that customer who spent the first 3 months on Selenium, tried to educate people, and then they took a different set of people with the same skill set and trained them on our tooling. They were very faster. And we got way further with that approach. So that was the reason why they then finally decide on what we do. So that was the second step. The first step from M1 to M2 made them second level of maturity. So how does the story continue now? The next thing was to really introduce test case design. Test case design as a methodology, as a technique to get to the most effective test cases and not produce redundancies in your test, but on the other hand, also make sure you really get to the business risk coverage that you seek. So what that means is that beyond these 40% business risk coverage which we just got by picking the most important test cases, we now are trying to increase the business risk coverage with additional test cases. A lot of our customers would try to do that intuitively. So they would take a little from here, a little from there, and add test cases because they have been confronted with this phenomenon of what we call combinatorial explosion. What happens when you do that is that the curve would not increase like this, but you would get to just an increased number of test cases, again and again, more test cases, which are gonna add up to high levels of redundancy, but not gonna increase the business risk coverage. In order to overcome that, you really need to introduce what we call test case design, and this is gonna push the business risk coverage. Then, when you wanna do that, and increase the numbers of test cases that you now need to deal with, we would recommend you to also think about API tests and not just go for the UI test automation. So first of all, we introduced test case design now to get to a very powerful test cases that cannot be found intuitively. And then we expanded the test automation and focus with the expansion on API testing. So do not stick to the UI test automation anymore. So why is that relevant? If you have a look at this agile test pyramid, which you guys are certainly familiar with and you've seen, you see that automated tests are supposed to cover basically the pyramid to a large extent. What we recommend is that all those automated tests you see here have a clear focus on API testing. So why that? API testing compared to UI test automation is way more efficient. The setup is 4x in the speed, maintenance is way faster, and they run significantly faster usually. And you can use them progressively. You don't need to have a full-blown user interface at hand. You can take the interface definitions that you do have from a WSDL or whatever and build the test cases against it. As I said, we would like to have that the dominant occurrence of test automation. So only a few of these automated test cases should actually be UI test automation. The other ones should be API. So that's what we did with these guys, extending the test cases, adding more UI test cases, but primarily focus on the APIs. The next thing to do was test data generation. What you're gonna find out when you come to more complex scenarios to be run is that test data really matters. And having that said, we also were supposed to generate and provide the test data which is suitable for the tests and provides a perfect match. For those who have ever tried it, you will find that test data may expire. Then whenever you run tests, you change test data per se, and through that you will consume it. So there's a series of issues you need to solve. What we actually do when we introduce this is that based from the epics and user stories, we would come up with the appropriate test data design, and these test data design would lead to test data generation or extraction, production data masking, whatever you do here, and the execution of the tests on the basis of that. Why do I bring it up? Please don't forget to do it. If you just jump into the automation without having thought about test data, you will be kind of fine, kind of on the level of unit tests. When you go a level higher with integration or with even with system integration, you will certainly need to take care of test data management. So that's what we did here. In addition, we made sure that especially these smoke tests, which we have come up with, are driven through continuous integration, and we made sure that the whole work suite which we provide in testing has been nicely embedded into the full DevOps tool chain. So continuous integration is a must, but I'm sure that you guys are aware of that. So that was basically the step into M3. So what people now had is they had risk-based prioritization, test case design. We had increased the automation. We had come up with here with test case with the integration to CI, and test data management was also here. So a little bit of that should be shown in this position as well. Then we decided to further expand the test to get to very high business risk coverage, and that was mainly API driven. So the UI test cases basically had been set. We were mainly API driven. And another thing we now had to tackle, given the complexity of the system we had been working on, was actually service virtualization. So service virtualization would allow you to simulate the behavior of connected systems, and through that, you want to make sure that complex use cases can be executed as if a connected system would be here in the right state, even though it might not be available today for whatever reason, or because it is not in the right code state currently. So service virtualization, the bigger your systems grow, the more it becomes important. As I mentioned, what it would do basically is the behavior of connected systems, say this is the application to be tested, these are the systems to be which are connected. This behavior of the connected systems would be simulated because it might be the case that these systems are not here available, or the development of them is in progress. If you do that, then you can simulate these whole business processes and test them in its entirety. If you go into the agile pyramid again, you will find that in complex environments, the test-driven service virtualization, that's what we call it, is more and more required the more you go to higher levels of testing. So that is what we did in order to bring this customer to M4. The last step was actually to roll these things all out, make the continuous testing comprehensive, and doing that, we introduced exploratory testing. Actually, that was a move which was pretty untypical because it was pretty late. Usually you would introduce that way earlier, which you see here in the chart. With this particular customer, we have been on late on exploratory testing, but we introduced it finally. And there's another thing which I would like to really point on, which I can recommend to each and everybody to have kind of a DevOps contract with development so that each and every use case can be administered via an API so that you can test the business logic behind through an API. That is gonna make the API tests so much easier to set up. A word on exploratory testing. On exploratory testing, what you typically do when you set up tests, when you set them up specification based, is you want to tackle a lot of risks, and this is done by a large number of test cases. When these test cases can be set dynamic, not static, all these lines would be static test cases, then all of a sudden, when you have the flexibility of an exploration, you're going to be very fast in tackling business risks and finding the most relevant errors. So we are very much believers in exploratory testing to find failures quickly, but be aware that you don't get to full business risk coverage with that. So some of the risks may not be caught by this task and this strategy. So that was basically it. Exploratory testing was the picture, made the picture complete here, and that is what took our customer to an M5. So this was actually an endeavor. The whole journey took not fully 6 months for the first steps, then to 12 months, just a year to get to an M4, and then to fully roll it out across the whole organization took about 1.5 years. So just to give you an idea what the journey is going to look like and how long it's going to take. And that was it. So I hope this made it a little tangible what a continuous testing journey means, which different aspects you need to take care of, which different steps you need to walk through. And with that, I would like to hand it back to our moderator of our webinar. Thank you.
Thank you, Wolfgang. Thank you so much. Actually, Nicole and Wolfgang, thank you both for some great presentations. We do have about 10 minutes or so for questions. I don't know if we'll get
Yeah,
to
I see some great questions.
I was just going to say, we've got some great questions. I don't know if we'll get to all of them.
I
Here's how
know.
I'd like to do them, though, Nicole and Wolfgang. Some of these questions will lend themselves to one or the other of you, but I want you both to feel free to chime in and give us, your take on it. Just don't step on each other with it. With that said, let's get started. Our first question is from Hans, and it's which segment are the elite performers compared with? That is,
Oh, for the boom stats, we
Yeah.
compare the elite performers and the low performers. And that's been true for all of the last 5 years. We've always compared the highest performing group and the lowest performing group.
Okay, that was kind of straightforward. Next, while looking into a more operational side of things, have you gotten an insight on some incident practices that maybe emerge as patterns among performance groups, such as, let's say, chat ops or dedicated crisis teams, or et cetera? Nicole, that's really, I guess, for you to start.
Yeah, we don't have data on that, at least in the ASODER, the State of DevOps study in groups, but I know that like Jason Hand has a bunch of good data there, and he's done some work on that.
Right, and that would be, I think, from the Victor Ops team.
Yep, from the Victor Ops team. Although
Yep.
Jason Hand also wrote a short O'Reilly book on that.
Yes, he did. Yes,
Yeah,
he
so
did.
that would be some Victor Ops and some Jason Hand. Sorry, let me do my quick
Something
Google.
like incident response or, yeah.
Yeah, post-incident reviews.
Yep.
So I would point people to Victor Ops and post-incident reviews by Jason Hand. Yep.
Excellent. Next question. Is there a correlation to multi-location teams, not functional outsourcing, and performance?
So I would say our data specifically looked at functional outsourcing. Okay, and I will also point out that functional outsourcing can be either like when you hand it off to a completely different organization, or it can be when you like do round the clock stuff, right? And you hand off like all of QA is going to go somewhere else, or all of ops is going to go to like another country, right? So functional outsourcing can be like within a company. Now the opposite of that can be, let me find my, multi-location teams. So a multi-location team can be fine and it can work, and we talk about this in the report. What's most important is that those teams are like the cadence of work and the rhythm of work is maintained, right? So it can be more difficult. And I've been working with teams and organizations over the last month or two. It can be a challenge, particularly once you hit like really long like time zone differences. But what's important is that cross-functional team maintains the cadence. And it can be even like with a team that you outsource or co-source, right? It can be external teams that you bring on as long as you really maintain that cadence of work.
Yep. So one last question for you, Nicole, is can you further define functional outsourcing?
And I think I discussed that just a tiny bit. So functional outsourcing is when you hand off like an entire, sorry, I'm going to be a little like reciprocal here, right? When you hand off an entire function, right? So like all of dev is handed off, all of test is handed off, all of ops is handed off, right? Like you silo off, you break off an entire group and you hand that off to either an external group or even like an external function somewhere else, right? That's where you run into big problems.
Got it. So now I think we're going to switch over to a few Wolfgang questions. Wolfgang, if you're ready.
Mm-hmm.
What are some of the challenges you have encountered to help the customer establish continuous testing?
Very good question. Actually, the biggest challenge that we have is that customers approach the topic way too naive, meaning they think it is UI test automation and that's it. What we see is that test automation, I call it a little provocative, is actually it's a series of nightmares. First of all, people come up with tests, but they don't think about the necessity to maintain them. So you better make sure that each and every test that you do contributes to risk contribution. Otherwise, you should not automate it. Each and every automated test is going to generate some effort on the maintenance side. I heard, well, if it's just automated, it's free anyway, right? So let's automate 10,000 tests more. That's stupid because you're going to suffer from maintenance. And then people run into each and every challenge which I mentioned. They run into test data management. They run into service virtualization as necessities. So without having gone through this, it's sometimes hard to believe. And so we try to educate our people, but some of the experience our customers need to do on their own, I'm afraid.
Don't be afraid. I agree with you. Okay, our next question is just a bit of a nitpick here. You had on the manual versus automated, the data was from back. I'm sorry, Nicole? No,
I'm so glad they brought this up. So yeah, I'm seeing this question. So it says the data on manual versus automated is from 2015, 2016. It's not. It's actually not at all. We recollected the data. So this is new data. And I'm so glad you brought this up. I sometimes I get a little annoyed and like lovingly roll my eyes at people who try to catch me right in my data, and I'm like, no, this is great. And I'm glad you brought this up because this is either the second or the third year we have found this pattern. This is like, and people are like researchers, you never reconfirm data. This is revalidated for at least 2, and I think this is actually the 3rd year we have found this. Right? And so people are like, oh, Nicole, you're recycling data. No, I keep re-asking this question because we're like, I wonder if it's still going to be there. We found this again, right?
Mm-hmm.
So by the way, somebody high five yourself for noticing this. This keeps showing up. Medium performers keep doing, at statistically significant levels, medium performers keep doing more manual work than even low performers.
Wolfgang?
Yeah, so thanks for jumping in, Nicole. I'm not sure what it was pointing to. Maybe it was pointing to this graph that I've shared where it said...
Pointing to my Jcurve.
Oh, okay.
All right, I had the wrong graph. I apologize.
No worries, no worries. It could be also tied to this 80-20 thing that I mentioned, where I said that still 80% of the testing is done manually. And yes, I've been using this graphic for several years now, and actually
maybe
yes,
they caught both of us.
and yes, you know what? I've been predicting that the automation degree is gonna increase significantly over the next years, but also yes, it did not happen as dynamic as I would have expected it. We still see, you see still there's the stats of last year. What was the extent of services out there? It was like 32 billion in US dollars. And all of a sudden, this has grown into 35 billion US dollars. You think that's because automation has kicked in as sufficiently as we would have looked for? It certainly has not. We still see a ton of testing done manually, spec-based. So although we all agree that the automation degree needs to be increased from this 80% to a way smaller number, it's not going to vanish. Let me make that clear, as Nicole has pointed out, but it is not as quickly as I would have expected. It just takes longer.
Thank you. So guys, unfortunately, we're coming up on the top of the hour here. We still have a dozen or 2 or more questions. If it's okay, Nicole, Wolfgang, we'll get you these questions in writing.
Absolutely.
And maybe someone on your team could, if you'd like to answer, we'll include them on the webinar page for this on DevOps.com. As I've told multiple people who asked, this is recorded. It will be available on DevOps TV as well as on DevOps.com within 24 hours. It's usually up in an hour or 2. But we'll have it up there for you. But more importantly, it just goes to show you what a buzz, what a interest there is in the market around continuous testing. And, you know, Nicole, and the work you're doing, obviously phenomenal stuff with insight into what's making teams successful. And with everything Tricentis is going on, I think there's little doubt that continuous testing is important. But with that being said, guys, thank you both. Thank you very much for Tricentis for sponsoring today. Most of all, thank the 1,200 odd of you who registered for today's webinar and maybe listening to this live or on recording for joining us. We hope you found it interesting. You can get more information, of course, at Tricentis, and in regard to Nicole and Accelerate and the whole report, State of DevOps report, at the DORA, D-O-R-A website. Thanks again. This is Alan Schimmel for DevOps.com. Have a great day, everyone.
Thank you.